Hello people, welcome back to the channel, and today we're going to be looking at practice exam questions for your paper 2 in chapter 8, which is rates of reaction and equilibrium. But before we get to that, I'm going to give a massive thank you to these guys over here who subscribe to the channel. Thank you very much, sharing the love, and without any further ado, let's jump into it.
It was a nightmare.
Activate.
All right, so question number 1 says ammonium nitrate NH4O3. All right, so first thing you want to make sure is that you identify and you know what's going on. So this here is ammonium nitrate. Okay, there we go. So we know that that is ammonium nitrate. It's produced by reacting ammonia, okay, and nitric acid. So to get that, you need to get those two together. Okay, that's the first thing you want to take in mind. Ammonia, you'll be looking for the formula for ammonia is NH3, and formula for citric acid will be HNO3. Okay, first thing you want to keep in mind over there. So what we got next, a student measure a mass of ammonium nitrate that dissolved in 100 grams of water at different temperatures. Okay, so what this person have is got water. All right, this is the temperature of water. Okay, and at 100 degrees, at 0 degrees, this is how much ammonium nitrate dissolved. At 20 degrees, that's how much ammonia dissolved. 40 degrees, that's ammonia dissolved. So you got water at different temperatures, and he's adding the ammonium nitrate to find out how much it actually dissolves. Now it says use the table above to plot a graph of solubility of ammonium nitrate on the figures below. Okay, so let's identify a couple things first. Okay, the thing that is changing is the temperature of the water. So this here is your independent variable, is what changes, and what you're measuring is the amount of ammonium nitrate that is being dissolved in 100 centimeter cubes of water. So what you're measuring is this here. Whatever results here will depend on the temperature of the water. So this one here will be your dependent variable because it depends. This is what you measure. So what you change and what you measure. Okay, those are the things you want to identify before you get into this question. Use the table above to plot a graph of solubility. Okay, so we got a table right here. Okay, now you always probably been told that in a table of result a plot, you want to use as much of the graph as possible. Okay, you don't want to have a little tiny graph here at the bottom, all right, or somewhere here in the middle. You want to use as much as possible so you can actually see the whole thing. Okay, so first of all, we got to identify that this will be your x-axis. All right, the bottom there is your x-axis. The top one up here is going to be your y-axis. Now in the y-axis, we're always going to write down what you are measuring. Okay, so in the y-axis, you're going to have your dependent variable, right? And in your x-axis is what you're changing, and that's going to be your independent variable. All right, so once we identify that, we have 1, 2, 3, 4, 5, 6 different types of temperature. Okay, and then if you look at the graph itself, what you would see is that it has been divided for you already. You got those big divisions. So you would say that 0 obviously is going to start from here. Then you can have 20, 40, 60, 80, 100, and so on. Okay, so it will be prudent to say that we'll have 0, and that one there will be 20. Okay, you want to have the same spacing in between the numbers, and obviously those numbers have to have the same difference between them. It's important that you always write down what you have here. Okay, so down there you're going to write down temperature in Celsius, because that's what the question is saying. All right, when you look at the table, right, it says right there temperature in Celsius. It's important that you always write down the units as well. Now the tricky part in this one is here, because the smallest result here is 119. You could technically start that at 100, but because we already write down the 0 down here, let's see this. If we go up in 50s, you will have 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. Okay, but because this is above 1000, you want to make sure that you cover that. I'm gonna start this down here, right? And that section there, we're gonna go for 100. There we go. You gotta be very, very careful with this, because a lot of the time the lines will just jumbled up on you and you end up with the wrong scaling, and that could be mean that you are missing marks. Okay, so we got 200. Okay, we've done that. You could also try to identify the 50s. If we're gonna look very carefully, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So half of that, 1, 2, 3, 4, 5. This line over here, that will be your 50. We got our scaling done. That will be 1 mark for you. And we have the labels, although we're missing the label over here in this side, in the y-axis. So we're going to write down the label, which it says that will be mass of ammonium nitrate in grams dissolved in 100 grams of centimeter cubes of water. Okay, it says to you here that you're going to get 1 mark for labeling this properly, right? Making those two the proper label, that will be 1 mark. You're gonna get another mark for the proper spacing or scaling of your graph. The other mark will be for plotting the points correctly, and the other one will be for making your line of best fit. Okay, so we got the first one there, that we got 0, and then you have 19. Okay, 119. Now what I normally do to make sure that I have a very, very good scaling over here is that if you think about every single one of these boxes that will be 100, 110, 120, 130, 40, and then 150. Each one of those little boxes represents 10, and if you're looking at 119, you're looking at that right there. This is the spot that we're looking at, and that will be your 119. When the temperature was 20, the measurement was 190. Okay, actually I made a mistake. It's 190. So there we go. We're gonna just cross that off. 190 will be here. All right, so we got 60, 70, 80, 90. So that will be 190. So really and truly, our first spot will be there. This is where your first spot should actually be. There we go. Your first spot should be actually there. The next marking that we're looking at is 286. And there we go, and that is your points properly located in your graph. You have all your points located in the graph. Okay, remember that this is the mistake that I did at the beginning, right? So the next thing you're going to do is you're going to do your curve of best fit. Okay, and you always omit your anomalous result. So what do you think your anomalous result be here? Okay, now if I follow this curve of best fit from here, right, and I go to there, it's gonna be looking like a very sharp turn. All right, so I would normally follow through here. That's more like a curve of best fit, right? And that would there be your anomalous result. Question B, at 20 degrees Celsius, 190 grams of ammonium nitrate dissolved in 100 centimeter cubes of water. Calculate the amount of ammonium nitrate in moles. Okay, so it's asking you, this is the command word right now, calculate. Okay, they're asking you to calculate the amount of ammonium nitrate in moles, okay, that dissolve in 1 decimeter cube of water at 20 degrees. Okay, those are the things that you need to remember before you start working. These are the things that you need to highlight before you start working on your equation to calculate the moles. Okay, so we got a 3-mark question. First thing you want to do is you want to calculate the relative atomic mass of ammonium nitrate. Okay, now in the previous question it gave you the actual formula for ammonium nitrate, so that was given to you in the previous question, right? So you gotta make sure you know that if it's question 1A, B, and C, and D, usually they are related to each other, and you're gonna find the information within the question itself, okay? Those are the 3 different molecules that we have in the nitrogen, hydrogen, and oxygen. Right. So nitrogen is 14, right? But you got 2 nitrogen, you got 1 there, and you got 1 there. So you do that times 2, which is 28. Then hydrogens, you got 4. Hydrogen is 1 times 4, and that equals to 4. Okay, and it's giving you the numbers here. This is why it's foundation. If it was a higher tier, you will have to look for those in the periodic table yourself. Okay, if you're lucky, they will give them to you, but normally you have to look for them in your periodic table yourself. It's not difficult, it's just a little bit of a process to go around finding them and whatnot, but this is just easy peasy. Okay, now and then we have oxygens. Oxygen says 16, but we got 3 oxygen, so you times that by 3. Okay, so you have 10, I got 1, 48. Okay, so you add all of those together, and then you will get your answer, which is 80. Okay, so relative formula mass of ammonium chloride is going to be 80. Okay, that's the relative atomic mass. So that's the first step that you got there. Now, step number 2. One thing you're gonna remember is that 1 decimeter cube is the same as saying 10 centimeter cubes. So 100 centimeter cubes will be the same as saying 10 decimeter cubes. Okay, 100 of those equals 10 of those, 1 of those equals 10 of them. Okay, so that's what you gotta identify next. Okay, so remember that to calculate the moles, all right, your formula for moles will be moles equals to mass in grams divided by the relative formula mass, and in this case we got to the point that it was 80. Okay, so this is what you want to find out. Now if it's 100 degrees, if it's 100 centimeter cubed and you have 190, right, you want to divide that in 10 because you got 10 decimeter cubes and 100 centimeter cube. So what you do is that you do the 190 times 10. Okay, that's going to give you 1,900 grams. All right, and once you have that, you have your mass. So you would actually be doing 1,900 grams divided by 80. Okay, and then your answer there should be 23.75 moles. Okay, so and it's very important that you write down your actual working out. That's going to give you a mark. Okay, calculating that's going to give you another mark, and actually writing down your answer is going to give you the other mark. Okay, if you just write down your answer with no working out and that answer is right, you get all 3 marks. But if you write down your answer and it's wrong, you will get 0 marks. So it's always important to write down your actual working out. Okay, and as you can see, the units have already been given to you. If you was doing a higher paper, you would have not been given that, and then you will be deducted mark if you didn't write down the actual units for it. Okay, now go to question C. Farmers use ammonium nitrate as fertilizer. Farmers want to slow down the rate at which the ammonium nitrate fertilizer dissolves in the water in the soil. Okay, suggest why they spread the fertilizer in the form of small beads instead of a fine powder. Okay, now this is actually taking you to the part of rates of reaction when we're looking at the things that affect the rate of reaction. Okay, now they're not saying anything about changing the temperature, so it's not going to be temperature. They're not saying anything about changing concentration. They're not saying anything about adding a catalyst, so they're talking about surface area. Now if you are given small beads instead of fine powder, if you have a small bead, okay, say like that, the surface area will be everything that is around it. Okay, but if you turn that into dust, right, you can very easily put all of that and then bundle it together and fit into that circle, that means that this has a larger surface area, and these things here can actually dissolve a lot faster. Okay, so if they add the ammonium nitrate in the shape of a powder, it's gonna get absorbed, it's gonna react a lot faster with the water in the soil than if you add a bead, because it got less surface area. Okay, you say that the small beads dissolve slower than the powder. Okay, and your second mark would be for saying that it has less surface area. There you have it. That will be your 2 marks in that question. Okay. Okay, so now we're looking at question number 3. Ammonia is needed to make ammonium nitrate. So you need ammonia in order to make ammonium nitrate. Remember in the previous question, it says there that you have to have ammonia reacted with nitric acid to get ammonium nitrate. So ammonia is needed to make ammonium nitrate. The reaction used to make ammonia is that you have ammonia being made, okay, and then you add the nitric acid to make the ammonium nitrate. But in this case, we're just talking about the ammonia itself. Ammonia is made of nitrogen and hydrogen, so they have that much nitrogen, that much hydrogen, and then you get two molecules of ammonium nitrate. Ammonium. Okay, so the forward reaction is exothermic. So if you look at this here, it's telling us that is a reversible reaction. So say if you go forward, it's going to be exothermic, meaning that if you go backward, it's going to be endothermic. Okay, so at equilibrium, about 35% of the nitrogen and the hydrogen are converted to ammonia at 450 degrees Celsius and 200 atmospheres of pressure. Okay, so at equilibrium, about 35% of the nitrogen and the hydrogen gets turned into ammonia. So if the temperature is this and the atmosphere's pressure is that, okay, 35% of this is gonna get turned into ammonia. Okay, explain the effects of increasing the temperature or increasing the pressure on the ammonia produced at equilibrium. Okay, so this is a 4-mark question. Now there's asking you to explain the effects. Explain the effects of increasing the temperature or increasing the pressure. Okay, so that is what you want to talk about. You want to talk about increasing the pressure, what's going to happen, what are the effects, increasing the pressure, what's going to happen, what's going to be the effect. Okay, so if you increase the temperature, the amount of ammonia being produced is going to be reduced, because if the surroundings are hot, remember the energy travels from hot to cold, right? So if the surroundings are hot, more energy is going to be leaving. Okay, it's going to be leaving and turning it into an endothermic reaction. Okay, and then moving the products to this side. Now if the temperature is reduced, then it will go into that side, because the temperature is going down, meaning that the surroundings getting cold. We know that an endothermic reaction gets cold because energy being absorbed into the reaction. So the increasing temperature of ammonia produced will be reduced because the reaction is exothermic. Increasing the pressure will increase the amount of ammonia being produced because there is less space available, meaning that these two molecules are going to be forced to combine into one molecule. There you have it. So increasing the pressure of ammonia produced will increase. Increasing the pressure, the ammonia production is going to increase because the ammonia molecule is smaller, so it needs less space. Because these two are bigger, like when they separate, as you increase the pressure and you make the space available smaller, what is going to happen is that those are going to force to combine and form the ammonia, meaning that if you increase the pressure, the ammonia is going to increase in production. If you increase the temperature, the ammonia is going to reduce in production. Okay, and there you have it. That will be your 4 marks. By saying that it will be reduced, that's 1 mark. Why would it be reduced? That's another mark. It's going to increase. Why will be increased? And then you have the other mark in there. That's a 4-mark question for you. Okay.